Hello guys. Today I want to talk about voltage divider, right? Voltage divider is one of those things that is one of the fundamental of electrical engineering. And for me, I am a person who is on my own journey, right? And every time that I learn something, not just learn it, right? I've learned stuff, and for me, it's just about making finding ways to make it intuitive. So for me, of course, we all know the voltage divider, right? We know if you want to find VR, for example, right? For example, we want to find the VR here. Let's see here. All right, let's say you want to find this VR here. All right, let's say this VR go to like it's a signal that go to some macro or something, right? Usually, what we usually think about, oh, so usually, right, we just use it like memorize a formula, right? Maybe like VR equal V in time basically R2 R1 plus R2, right? This is great, right? But the thing is, I feel like a lot of time memorizing formula is not bad, right? That's the start, right? But I think as you go along, right, you don't want to memorize formula because if I can change one thing here and this formula does not apply anymore, right? Because this formula is great, right? Because it's good to know the formula. But what if, for example, right? What if my reference here instead of being to ground, let me change that. Right? What if the reference here, of course, I know we are grounding this, right? Then of course this formula is great, but what if for some reason, I don't know, the reference is all of a sudden to 1 volt or 3 volt, right? You're gonna change the dynamic, right? So really for me, I feel like I'm always trying to find like the more intuitive way to understand this, right? What is really happening here, right? And for me, one thing I realized is that with time is, oh, really, all that's really happening is, if I'm looking at this, right, there's a 12 volt, right? It's reference to ground, right? So ground, ground is just a reference point, right? So there's 12 volt, and this 12 volt had to be distributed across all these resistors, right? It have to. So that means from this point to this point, 12 volt has been dropped across these two resistors, right? Okay, great. But really, for me, when I look at this, right, I feel like the real thing that's really happening here, right? I think something we don't really think about a lot that it really is now written. Since my reference here is zero, is ground, right? Usually we don't write it, right? But really, the real true equation is zero plus. You're gonna see where the zero is coming from, right? Because it's ground. We don't write it, right? But what I'm trying to say is what if this is, I don't know, this could be 3 volt, right? Then that means you have to include it, right? Because for me, what I'm trying to make sure that I understand this when I'm doing my circuit, I'm trying to make sure I understand it to the point where even when the variable changes, I'm not lost, right? So this zero is where the ground. Again, we don't need to write it, but I think it's very important to see it to understand what is already happening, right? But now let's go to this other thing, right? Then really what is happening here is really plus, let me put this right here. Then you have your V in, right? Usually we just do, oh, V in, uh, V in time R2, R1, R2 over R1 plus R2 is great. But really what is happening here, as you will see soon, is that yes, this is V in. But again, right, this V in here is being dropped across all this voltage with ground being a reference, right? So that means whatever voltage that's dropped here is really 12 minus, right, the ground, right? Because for example, if this was 3, if this was reference to 3, then mean the voltage that's being dropped will be 13 minus 3, right? But because it's ground, it would just be V minus 0, right? But again, we don't write it, right? Now, all that multiply by what? R2 over R1 plus R2, which I would say is great. But again, a lot of people still don't understand where exactly, why are we doing this? Where did that come from? Right? What do we use R2 over? Really, if you think about it, this R2 over R is coming from where? We know the voltage difference, right, between, right, this 12 and whatever the reference is here, right? Our reference is ground, right? Whatever voltage there's the voltage difference between V in and the reference is being dropped across this whole resistor, right? And really what is happening here is that the way I view it is that that difference, right, which in this case is V in minus 0, so that 12 volt there is being dropped, right? So it's really being dropped across what? All the resistors. So really, because now 10 ohm plus 5 ohm, right? So 12 divided by 15, right? You see? So basically, what I'm doing right now, I'm just finding the current right here, guys, right? Because our goal is to find VR, right? Again, as I said earlier, there is a voltage drop across all these resistors, right? But we all know V equal R, right? Yeah, we all know V equal R, right? As I said earlier, right? I'm trying to really tell you guys where this stuff is coming from, because I know in the beginning this stuff sometimes can, if you memorize it, it's great, but if you don't really understand it, in the long run, if you forget the formula, things can be a little bit difficult. But basically, this right here, right, all divided by R1 plus R2 is really coming from there, right? Because there's a voltage drop across this all these resistors, right? And that equates to a particular current, right? So the current that's flowing through both of these resistors, right? That's why we have that, right? Because again, the voltage difference that drop across all the resistors is 12. Again, right, in this case, our voltage is, the voltage difference between is 12. Our reference is ground, that's why it's 0. But again, if our reference was 5, you have to make sure you put a 5 here, right? I'm putting 0 because I want to make sure I'm making everything visible for people. Because a lot of time, since we just used to just like ground is just 0, which is good, but a lot of stuff become invisible, so we don't think about it once things change, right? So I'm just making everything very visible. And like I said again, so the current flowing through these two is really 12 divided by that, by 15, because I, all of a sudden, right, I equal V over R, right? That's all I'm doing here. Again, that's how we got this. So now, this is giving me what? 12 over that, right? You can divide both of these by 3, 4 over 5, right? So this part, right, the VR is coming because for me to know the voltage drop, because finding this voltage here, finding the VR, finding the voltage at this node, right, is nothing but basically I need to know what is the current that's flowing through here, and when I know the current that's flowing through here, I'm just going to multiply by what? By this, by the by the by the resistor. That's basically all it is. All right. So now once I know, okay, the current flowing through this, all this resistor is 4 over 5 amp, right? Now what do I do? Now I'm trying to find this voltage here, and that voltage is done by what? By basically saying, all right, V out there now all of a sudden become what? I know the voltage, I know the current basically that's flowing through all this, right? So all I need to do now, what is the voltage that's being dropped across this, right? And that voltage we get, we know V equal atom R. We know I. I is, our current is 4 over 5, right? And we know our resistor, 10, right? So now this is equal what? So VR equal what? 40 over 5 volt. Hey guys, this is something I just want to share with you guys, and you just make things very intuitive, right? I hope this video helped you guys in some way. Thank you so much.